You. Awesome. Okay. I'm so excited about our next speaker. Dr. Tamatay is going to be talking about dreams of data, the promise of AI for Kentucky healthcare. And Dr. Tay specializes in pediatric emergency medicine and is an AI research fellow with the National Board of Medical Examiners. He leads AI initiatives for UK healthcare and across the state. And is founder of the AI incubator at the UK College of Medicine. I think what is most amazing about him is that, again, he talks faster than me, which is, I always appreciate somebody who's a fast talker. I'm a fast talker. But he has a tremendous energy and he knows so much about this topic. And I think will help us with his expertise to allay some fears and figure out what the future will look like. And I'm so excited to have him here. So Dr. Tamatay, join me and welcome him.
Gosh, thank you so much, Trudy. That's so generous of you. Hello, my name is Tama. I'm one of the pediatric emergency medicine docs, like she said. Gosh, you are such a good MC. There are so many things I need to learn from you. So we are going to talk about AI today. And a lot of times whenever you talk about AI in a mixed room, you're going to get these two big bimodal peaks where some people are super pumped and they're all about AI. And most of us are like, I know it's something that I'm supposed to be getting into, right? Like I know that our data is supposed to be used for some other thing, but boy, the investment of trying to figure out what it is. And so my goal is to try to bring those two groups of people together because I'm getting some positive little micro nods from the audience of being like, yeah, that's kind of how I feel. A lot of the things that, just to make this a little bit more exciting, a lot of the things that you're going to see are all AI generated. We generated this in our basements. And so just to give you an idea of the things that are capable of using AI, one of the things Matthew Coleman and I had a conversation, he's the director of the Office of Rural Health. He and I were talking about, how can you use AI for things just outside of patient care and stuff. And one of the things he was talking about was using it for social media and logos and things like that. And boy, that's an easy use case. That logo that you just saw took about 45 minutes to put together. And so, the idea that I'm hoping to drive home is that there are so many opportunities to use AI beyond the things that we're going to talk about here that were not possible even just 3 years ago. And so the way that this talk is going to go is we're going to talk just broadly about how people are using artificial intelligence in medicine in general. And then we're going to move into what are we doing at the University of Kentucky. And then finally, the most important part is how can we work together to bring AI to elevate the way that we practice medicine in Kentucky? Because I'm convinced that artificial intelligence can improve patient outcomes and can decrease the amount of time it takes to see a physician. It can improve our physician shortage. I think there's a lot of opportunity. And the tricky part is that it's going to take a lot of work to get to that point, right? And so how do we get over those barriers? So when you talk about AI in healthcare in general, these are the things that people talk about. This is from the New England Journal of Medicine. And they talk about research and education and patient care. And I don't love this image because what's missing from here is administration, right? When you think about healthcare, how much of that time and money is actually spent on administration? And whether administration in your minds, and I know that you are probably more know about these problems than I do, but when I think about administration, it's more than just like documentation, and it's more than just billing and coding and things like that. There are so many things that we can be offloading to artificial intelligence so that our physicians can be at the bedside more, that our nurses can be at the bedside more, so that you don't have to spend all of your time responding to insurance companies explaining why this person actually needed this thing that was rejected for whatever reason. And so while we are going to talk mostly about patient care, a little bit about research, some education, I want in the back of your minds to also be thinking about how can we use this for administration. This was a paper that was published earlier this month in Nature Medicine. It's a pretty comprehensive look at all of the different ways that people are using artificial intelligence for medicine in general. And it breaks it down into the things that you've heard of, X-rays and imaging and ambient listening technologies, and then like looking at pathology slides and looking at dermatology slides. And so the point of this is just to say that most of this talk is grounded in evidence. By the end of it, though, we're going to start stepping out onto where can we actually take this, which isn't very evidence-based right now. There is a huge tidal wave, right? Like you can't check your email without hearing something about how somebody is using artificial intelligence for something, right? And everybody is trying to sell you a product. Everybody is trying to develop a product. Everybody wants to be Google. In my mind, we are not even at the Ask Jeeves phase of artificial intelligence. We're still at the AOL online portal where you go in and you check in for like 15 minutes out of your day, and then you turn off the internet and you're done, right? That's where we are with artificial intelligence. And so everyone is trying to figure out, how can we optimize AI? And so you're going to hear, and we are constantly flooded with these opportunities. And here, take my course and buy my product. And at the end of the day, I think there's a lot of value there. And we need to figure out, how do we take those little nuggets of value and turn them into actual patient differences? I'm going to be very brief about my history lesson. This is Frank Rosenblatt. I think this is the first AI machine. This was designed before the words artificial intelligence were coined. That was in 1956. This is 1954. Essentially, those Scantron sheets, what he's doing is he's using a computer to look at that and compare to essentially just a model. And he's using a computer to analyze data. Is your Scantron accurate? Which of these things are not true? I think that's the first use of artificial intelligence. And so when we think about AI in general, there is that historical standard AI of, does this pattern match what this historical pattern is? And then since then, there's been an explosion in machine learning and deep learning. And this is the person who's responsible for that. So this is Geoffrey Hinton in 2024 winning the Nobel Prize for propagation. That's essentially what has created artificial intelligence as you and I understand it right now. And that's all I'm going to talk about for history, just to say that the reason that you're hearing about it so much is because so much has been developed just in the past 5 to 10 years. This is the first use of artificial intelligence in medicine. Essentially, Stanford back in 1970 put together this algorithm which looks at cultures. You get blood cultures, you put them into your incubator, you pull them out, and then somebody has to do a bunch of stains, and then they have to do comparisons, and it takes a couple of days, and then eventually you get to what is the type of bacteria. And so they decided, hey, all of this is just rote memorization of this step, and if-then ideas and concepts. And so can we have a computer do the whole thing for us? And it did. And it is great for that kind of like algorithmic thinking. And this is what artificial intelligence was up until about 2017. It was all just algorithms, right? It's a decision tree. If this, then that. This is an example of some of the research that we're doing at UK. Very quickly, essentially, when somebody's in a bad car wreck or something and you're worried about bleeding into the abdomen, you can use an ultrasound to see whether or not they have fluid there without having to take them to a CT scanner or to an MRI. And it's not a very difficult study. And so we essentially taught a computer to do it for us. And so we loaded up a whole bunch of images of normal right upper quadrant ultrasounds and a whole bunch of images of abnormal right upper quadrant ultrasounds. I'm going to pause for a second, because I know there are physicians in the room, to say that I know that this is not an accurate slide, and that about 80% of those images are actually true positive, but a couple of them are actually false positives. They're actually negative, like the ones in the middle. This slide was created for me by an AI, and I thought it was funny to include it in an AI talk, because we are going to talk about hallucinations and when AI breaks down. So back to our little group. So that image in the far left of the screen is essentially what the computer is paying attention to. What you're seeing there is a heat map. Where it is red, it is saying these pixels are more important. And on the back end, what the computer is doing is it's saying, okay, I think this blob here is a liver, I think this blob here is a kidney, and I think these black pixels stuck together are free fluid, and I think this person is bleeding into their abdomen. What's important to know about this is we didn't tell the computer that. We didn't tell the computer, hey, look for a blob and some black fluid. We didn't tell them what fluid even means. All we did was we loaded up thousands of images and said, all of these things are positive, figure it out. And the computer was able to go through and say, okay, well, I'm going to start to figure out what's the difference between these thousands of positive images, these thousands of negative images. And the computer is telling us on the far left that based on your training data, that this is what I think is important here. The reason I call this out is important for a couple of reasons, because we want to make sure that the AI tools that we're using are transparent, that we understand when we get an output from an AI, why did it give us that output? And so when you're building a good system, you have to be able to go back and assess why did it give you the output. And the other reason is because now the way that our data is working, gosh, Danielle was up here talking about K-High and a data lake, and there are some of us, the nerds in the room, are starting to salivate. Imagine having all of the data of every person in Kentucky so that you could figure out what the differences are between the abnormals and the normals, right? Like how much power could you get out of that? And we're going to talk about that in a second, but boy, God, I got super excited. This is a transformer. This is why AI is so popular right now. This is what powers ChatGPT and Gemini. I'm just checking on my time. This is the first study that came out about how can we use large language models for in healthcare. This was a study that was published in 2023. I think it was either in JAMA or Nature, but essentially they compared how does a physician respond to comments and questions from a patient versus how does a chatbot. And I think by now everyone's heard that chatbots are pretty good. They're pretty good at coming to an accurate quality comment in response to a patient in comparison to a physician. They're even better at being rather empathic about it because if you ask a physician a question that they've heard 100 times, they're going to answer as though they've heard this question 100 times. But a computer can be trained to be very thoughtful and be very effusive. And sometimes that's good and sometimes that's not good. So this was back in 2023. So again, this is AOL time. Whenever you talk about artificial intelligence in medicine, the phrase that I hear most commonly is that AI is not going to replace physicians. Physicians who use AI is going to replace physicians who don't, right? And that phrase came out of this study and many other studies, but this is the big one. This is Nature. Essentially, they looked at three populations. They tried to get to an accurate diagnosis, and they asked a bunch of physicians to do it by themselves and GPT-4 to do it by itself. And then they brought those two groups together and they compared how did everybody do with their diagnoses. On the far left is GPT alone. In the middle, it's GPT and physicians. And on the far right, it's physicians. And so you can see physicians are lower than the AI was. And so already, as of GPT-4, which you'll see that was received in August 2024, and so they were doing that study earlier in the year, so we're already 2 years out from this study. Already, ChatGPT is better than physicians at coming up with diagnoses, but we make the argument that physicians with ChatGPT are better than GPT alone, so at least they'll still have a job, right? Maybe is the answer. So this is just a list of the studies that I've found so far where AI is now outperforming AI with a physician. And I'm going to be very clear when I said that maybe I'm going to be out of a job. I don't think that AI is going to replace physicians. I am confident AI is going to replace certain tasks that physicians do, and that AI is going to make us a lot more effective. I think that the huge physician shortage that we're facing, not just in America, but Kentucky specifically, is so almost insurmountable that I think AI can help with that if we just allow it to do some tasks for us. But when you look at the literature, we're starting to reach a jagged edge of the way that artificial intelligence is performing. Because where it used to be that physicians and AI was better than physicians, now when you start adding us into the mix, we're doing worse. And on top of that, when you think about all of the rote things that you do, like let's say, it is well known that artificial intelligence can get through 10,000 chest x-rays in about an hour. And it can flag the 5 or 10% that maybe somebody else should step in and look at and see, imagine if you were a radiologist, how long would it take to read 10,000 chest x-rays? And now you take that and you apply it to all other applications for medicine. You're thinking of pathologists and pathology slides. I talked to a pathologist at one of these AI conferences now 6 months ago, and he made the comment that, if you bring 5 pathologists onto the same slide and you ask them your opinion, you'll get 6 different opinions. And so already humans are somewhat fallible, right? And so we get a little bit worried about hallucinations and the human in the loop. But I would say that in general, the literature is telling us that having an AI with you is very helpful. And I think about that in the emergency department a lot. I'm going to start to go a little bit quicker. To make a long story short, I work in the pediatric emergency department. Somebody comes in and they look like they have some pus behind their ear, and you have to make the decision, do I treat this with antibiotics or not? This is the algorithm that you go through in your head every single time you run into that, right? How long have they had this? How long have they been feeling bad? Do they have a fever? If they do have a fever, is it greater than 102.2? If so, if it's greater than 102.2, have they ever had an ear infection before? And you're running through this algorithm in your head. And when I'm training my residents, I'm trying to impart all of those things because they see this kid who has pus behind their ear and they're like, give him antibiotics. And I'm like, no, you have to, what if you looked behind somebody's ear and you said, oh, he has an effusion. And then in your ear, somebody says, oh, you should not treat this because he doesn't meet certain criteria. And then it cuts to the chase, right? Every single time a human being has to run through this algorithm, I would argue we are failing our patients because I think that a computer could do that better. This is the choice of your antibiotic, right? How long should you treat them for? What's the dose? Should you use amoxicillin? Should you use cephalosporins? And so there are a lot of things that we can offload to artificial intelligence. I'm going to be very brief. We use open evidence quite a lot. I use it on every single patient. The other day I walked in at 6:55 and one of my residents had a 4-day-old whose heart rate was 290. Didn't have any P waves on their EKG tracing. We're like, okay, great. Let's give them some adenosine. And I said, do you know the dose of adenosine? And he said, yes, it's 0.1 milligrams per kilogram. I said, that's correct. It is 0.1 milligrams per kilogram. Let's call the pharmacist to get 0.1 milligrams per kilogram of adenosine. She's like, great. When then she brought it over and we didn't need to do it because the baby converted on its own. But because I use open evidence for everything, that's not true anymore. It used to be 0.1 milligrams per kilogram. It was 0.05 milligrams per kilogram between 1993 and 2004. And then between 2004 and 2024, it was 0.1 milligrams per kilogram. But this paper came out and wasn't very well circulated that essentially says that we recommend just starting with 0.2 milligrams per kilogram. And now that hasn't been introduced into textbooks yet, and that hasn't been widely circulated. And when you think about the vast amount of medical literature that's out there, 1 million papers were written in 2023. How many of them do you think your physicians are reading? 10 a year, right? 20, hopefully. We can't keep up is the thing. And on top of that, the people who are doing research are doing it at such a rapid pace. Why should I remember that the dose of adenosine is now 0.2 milligrams per kilogram for a 4-day-old? At what point does it change from a 4-day-old to a 6-month-old, right? It says it fails in many infants, so we recommend or it is reasonable to start with it. Well, what does it mean to be an infant? You know, at what time do you turn from not an infant to an infant, or I guess that's vice versa. All of this to say that if you had an algorithm working with you, boy, wouldn't that be great. And the first response that I get from people, again, I'm going to go faster. The first response I get from people is that they hallucinate. AI is not great. I can't trust it for my patients. This is how fast things are moving when it comes to artificial intelligence. So this was 2023, DALL-E 2 versus DALL-E 3. DALL-E 3 launched around the time GPT-4 came out. Just by context, GPT-5 has been around now for a couple of months. And so this is the pace with which we're improving, right? When AI first came out, everyone was like, it's hallucinating. It told me to eat glue for whatever reason. And so on the left, so this is the exact same prompt. And I don't love image generation when you're testing out AI, but that gives you a visual representation of the difference between DALL-E 2 and DALL-E 3. The guy on the left doesn't even have shoes on his toes, right? And on the right, like you could put that on your anyway. This is what I asked it for, this abomination. I asked it for, show me an image of a baby getting an ultrasound, right? And it gave me what looks horrifying. And 6 months later, it gave me a Greek sculpture. This is an example of video. So this was now 10 months ago. On the right is, on the left is me and my sisters. On the right is my Welsh Irish grandmother turning and becoming Asian. And the reason that happens is because this is high luo. So the point of this is to show you why training data matters. When people talk about data, the training data matters because high luo is a Chinese product and it's trained on 1 million Chinese women. And so when my Welsh Irish grandmother turns to the side, she becomes a Chinese woman because it's pulling from its data in order to fill in the blanks. And this, I swear, becomes relevant later. I'm giving a, that's a deepfake. So I'm giving I'm the course director for the undergraduate literacy course, and this was on image generation and deepfakes, and so that's why I made this. And but this is where video image generation is right now, right? Like I look not bad. Um, Sorry. Okay, moving forward. So what are we doing at UK? So this is our Innovators in Medicine that Trudy mentioned earlier. This is a group of medical students who are trying to answer and solve problems in healthcare using artificial intelligence and technology. And we have a bunch of examples of the things that they are doing. But this was from September. This is a video about vibe coding. And this might, Raymond, this might break the system. But if anyone has never coded before, I had never coded before these systems came out. But what you're seeing on the left side of the screen, kind of in the middle, is the actual code. And what you're seeing on the right side of the screen is an artificial intelligence system writing the code for us. So in real time, we built what is essentially a stock market tracker. And we talked about it, and like, these are the things we wanted to do. We described it to the artificial intelligence, and it built the entire system. All of that is automatic. It's just happening. It's populating databases. It's creating code out of nowhere. So much so that this was a product. So one of the things that we did was we walked around the emergency department, was like, where are your pain points? How can we make your life better? And one of the nurses said that it is difficult for me to understand what is going on with all of the other nurses in my department unless I open up every single chart one by one and see which medications are due, when we need to send somebody to radiology, et cetera, et cetera. And so we thought, what if we created just a dashboard that you can just glance at? And then what you're seeing on the screen is that's the app that he made as well, so that now there's also a communication system so that nurses can talk to each other. And also, if you see that, Jen's been in a code for an hour and a half, maybe I can help her out. All you have to do is look at the screen and there's a little timer that's going down. He built all of that in 4 hours. When you talk about software development before AI development, just getting to an app is already $50,000, right? And then anything else you want to build from that starts at $50,000. He did no coding. He used no lines of code. He just talked to it for a little while and built an app and an entire dashboard. That's the promise. How can we leverage this technology to make our patients better, to make healthcare better? This is some software. I'm actually going to skip this one. It's really cool, I promise. But I want to get to the end where we get to talk about some of the stuff that we're doing. This is all the things that our Center for Applied AI is getting into in regards to applying artificial intelligence to medicine. And you're seeing UK healthcare, you're seeing pharmacy, you're seeing College of Medicine. Those are each individual projects about how can we use AI. There are so many people doing AI that they're doing some cool stuff. So this is Gia Bay. She is doing some AI research on patients who have epilepsy, and she's using EEGs essentially to look at your EEG tracing and to decide what parts of your brain are diseased based on neurosurgical outcomes, so that when you are in neurosurgery, you can make changes in real time, right? You can put leads on the patient's head instead of needing to send them to an MRI scanner while they are already open, so you can make changes if you've already done a resection. Did you get all of the diseased area, et cetera, et cetera. She's doing really cool stuff. The only reason I knew about her stuff is because our kids are friends at daycare. Like, there are so many people doing AI stuff that is just like revolutionary. And in 10 years, it's going to be changing people's lives. And the question that I have, and the question that I'm hoping that we can all answer together, is how do we harness all of this to actually make a difference? And so we talked a little bit about like some, interesting research, but I'm of the opinion that the research is done. If we did not advance medical knowledge around artificial intelligence any further than where it already is today, it would still take us 20 years to take all of the revolutionary technology that's been discovered in the past 10 years and actually apply it to our patients. And when I think about remote patient monitoring, right, like Danielle had a slide about using K-High, you can update your A1Cs and stuff. What if we all have these continuous glucose monitors when you have diabetes, not we all, but people have these continuous glucose monitors. What if all of that data got uploaded into an AI algorithm so that it could, in real time, give you recommendations about what is the dose that would be best for you specifically, right? Instead of the dose that we thought was going to be right for you the last time you saw your endocrinologist, which was hopefully in the past 6 months, but may have been even longer. Or what about, actually, I'm not gonna steal from my slide later, but I think about this. I think about Kentucky in general. And Kentucky is unique, right? When it comes to the data that comes out of Kentucky, the reason I am so excited about that data lake that she was talking about is because our problems are different from people who have problems in New York, in California, in Brazil, and Scandinavia, where all of these models are trained, right? Because we're using tons of knowledge. You think about Cosmos, which is the epic, data lake, which has some hundreds of millions of data in it. When you take those models and adapt them to your local environment, a lot of times they fall apart. And we did that ourselves. There is a sepsis model that, you think about sepsis and how every single hour that you don't recognize sepsis, you're increasing your mortality rate by 9%. Boy, what if we deployed AI so that we could figure out who's in here is going to get septic? And if we can find you 4 hours sooner, right? Like not even a whole shift sooner, a third of a shift sooner. If we can find you sooner, then that means 9 plus 9, it's like 36% your mortality goes down. When we tried to deploy one of those models, it was garbage. It did not work. And the problem is because you have to go back to your training data. You think about my grandmother who turns to their side and now she becomes Asian, right? If your training data isn't trained on the population that you're trying to deploy it on, then you're going to get Asian women. That sounds weird. Sorry, okay. All right. But so these are, so when I think about like kind of the big things, you think about like pediatric brain tumors is like 60% higher in Kentucky than it is all across the rest of the country. Heart failure is higher, cancer is higher. We have the 47th worst outcomes when it comes to our healthcare, 45th in the country when it comes to maternal mortality. And when you look at the patients who die in and around childbirth, those patients overwhelmingly are on Medicaid, which means that we have their data. It's about 78% are on Medicaid. And when you do a morbidity and mortality review of patients who die in and around childbirth, 91% of those could have been avoided. That's not my statistic, that's their statistic. And so what data is there that we could have intervened? What data is already existing and now gonna be collected into this giant data lake that we can get into and say, I want that, I wanna fix that. You look at Kentucky Medicaid, it's 28% of the population, and out in Eastern Kentucky, it's up to 54% out there. It's more than half of children in Kentucky, and when you look at how much Medicaid costs, it's $20 billion. And so do you think if we had artificial intelligence, could we make Medicaid 1% more efficient? Could we decrease that cost by 1%? Because that's $200 million. And so we've done some analysis, and we think that if we deployed AI in the right ways, we could get that number to 3 to 7%. That's a huge chunk of cash. And so the other thing that I think about when it comes to health outcomes is the places where we have difficulty are the places where it's difficult to access, right? You think about Eastern Kentucky, you think about these big mountainous areas, a lot of them, even though we spent hundreds of millions of dollars on this broadband project, a lot of them still don't even have internet. And so how can we take the promise of artificial intelligence and make those people's lives better, improve healthcare out there? Do we not rely on the internet at all? Do we then think about like cellular signals? Because, and to be honest with you, some spaces out there don't even have cellular signal. But do we think about leaning into telehealth more, right? Instead of requiring or expecting that physicians are going to go out there or providers are going to go out there, instead bring healthcare to them instead of make them come to us. And so these are a couple of the projects that we're working on. Some of them are internally funded. Some of them we're looking for partnerships with the state. This one is, I think, pretty simple. So this is a predictive model for congestive heart failure. When you think about some of the most expensive and life-changing diseases, we think about heart failure kind of right at the top, right? And heart failure is tricky because those admissions can take weeks before you get somebody's heart beating better. And so can we deploy a predictive model to identify the patients who are at the highest risk for bouncing back to the hospital? And if we can find those 20 to 30%, can we intervene a little bit more? Can we show up at their house and make sure that they're taking their meds? Can we give them all a scale? a scale that's connected to the internet that probably costs $75, that they weigh themselves every single day, and so that you can identify when are they starting to retain fluid, when are they starting to go into heart failure a little bit earlier, and then can we prevent a $10,000 admission to the hospital? Can we make their lives a little bit better so that they're living healthier lives out in the community? This is all part of the Advancing Kentucky Together network. I am not going to talk too much about it because Trudy already did earlier today. But the summary is we think about healthcare, we think about education, we think about workforce. When you think about, am I going to try to deploy AI out in an independent hospital, right, or out in the community? It's more than just taking the technology and turning it on. I had a conversation outside with somebody who was, talking about Microsoft deployed a rural health program to try to bring AI into rural health. And there is open source code out there that you can take. And so that when you get some of your claims denied by insurance, this source code essentially goes over the claim and writes up a rebuttal, right? That's awesome. I'm so glad Microsoft is doing that. But how are we going to do that? Like if I was in charge of a hospital, and I had source code in front of me, and I'm trying to decide, okay, what do I do with my data? Is this going to be HIPAA protected? How do I need to set up a server? Like they might as well have, written that little message into a bottle and shipped it into the ocean for how much it's going to help me, right? And so we think about not just how do we create healthcare innovation, but how do we actually deploy it? How do we actually bring it out? And that's why I want to save time, and I keep looking at my clock. I want to save time at the end because I want to have these conversations to understand what are the things that you are using AI for? How are you thinking about integrating AI? What are the things that you want to integrate AI, but you just haven't been able to because maybe you haven't found the right vendor, the right partner, or what have you? This one I think is really cool. So hepatitis C, we've cured hepatitis C. I mean, not we cured hepatitis C, but like people have cured hepatitis C. There's a cure that is 98% effective if you just take your medicines right. And when you think about who has hepatitis C in Kentucky, overwhelmingly they are on Medicare or Medicaid because you're talking about populations who are IV drug users or homeless or in the sex worker profession. And so it is tricky to get them to take medicine. And we have data that says that we're about 60% effective at treating hepatitis C. The other problem with hepatitis C is that it costs $10,000 a month for some of this medicine. And so and it's not just once a month, or it's not just 1 month and you're cured, right? Like it takes a lot. But on the other side, if you can cure hepatitis C, this is a communicable disease, right? And so this is the most common cause of infectious disease to cancer when you think about hepatocellular carcinoma. You think about cirrhosis. And so what are the downstream effects of not curing hepatitis C? And so can we not cure hepatitis C because we've already done that, but can we social engineer? Can we use AI to make people just better at taking their medicines? That's all I want. And so we're partnering with, this is a company called Docentrics. So Docentrics, this device on the backside, what you don't see is it's a pill bottle. It's a pill bottle just like you used to play with growing up where you put your M&Ms in the thing. It's a pill bottle that it has smart technology built into it so that every time somebody takes their medicine, it sends out that cellular signal. And then so now we are writing an algorithm on the back end at noon and 9 p.m. We check in with every single patient who hasn't taken their meds. And we've got an AI agent that does that, and it turns it over to another AI agent. That AI agent, and I'm going to cut to the chase, I promise. And essentially, we reach out to every single one of those patients. And whether that's by calling you on your landline, or is that a text message, or is it a Facebook message? Because the way that you communicate with the world is you have to go to the library and log into your Facebook there. This is what the promise is, right? Like this technology isn't revolutionary. Like this isn't protein folding and genomics and transcriptomics. This is just the AI systems that we've already developed. Can we think of creative ways to use it in order to make healthcare a little bit better? I pushed the red button. So Danielle was also talking about preventative screening when she was here and talking. One of the things that we were thinking about is if you look at Medicaid claims data, you can see which patients are due for a colonoscopy and which patients haven't had that colonoscopy done, right? That's an easy check. The hard part is getting them actually scheduled and bringing them in and explaining what is a colonoscopy and why are you calling me? And how much labor does it take to bring one person in for a colonoscopy? What if we created an AI voice agent that does all of that for us, right? That crawls through the list of people who are due for their HPV vaccine or their mammogram and reaches out to them and has a conversation and says, hey, just so you know, you are due for a colonoscopy. And then the person says, what's a colonoscopy? Let me explain it to you. Has everybody here talked with a large language model or an AI? I'm getting a lot of nods. Okay, you will know that the first couple of times you used it, like, that's creepy, right? Like, you talk with this thing and it's talking back. It is not you're going to Wikipedia and you're looking up stuff. Like, it knows stuff and you're like, okay, this is weird. Now turn that into a cell phone conversation, right? It's like, what is a colonoscopy? Oh, well, just so you know, you're at risk because of these things. And it's pulling information from your data. You're 55 years old. Your father died of colon cancer. These are the reasons that we need you to get set up. And then on top of that, it goes a little bit further. You're going to see Dr. Ballard. He is on the 7th floor of UK Chandler Hospital. This is where you're going to park. And it does all of that all in one phone call. It's connected to your EMR so that it schedules all of that. So they're like, okay, well, scheduling is really difficult. How about 2 weeks from now? And say, yep, we have a slot open. It does all of that for you. That's what we're trying to build. We were partnering with another big company that you've heard of, and we built a prototype that essentially does that. And we think we can deploy it. But what if you took that same thing, that same device, and then looked at all of the other ways that you could use it, right? It's not just calling somebody to say, hey, you should come in for a colonoscopy. What if you automatically called every single patient 48 hours before their appointment just to check in, just to make sure that nothing's changed, right? Do you have transportation? Are you going to be able to make your appointment? When you look across the country at people who are doing this, they decrease their no-show rate by 40% just by using some kind of artificial intelligence reminder, just a nudge. Hey, don't forget, it's 8 a.m. And then what if they say, nope, I'm sorry, I can't make it? Then great, then automate the process. So then another automated process goes through and it texts every single person on the list. It goes through one at a time. Hey, just so you know, Thursday at 8 a.m. opened up. Is this an appointment that you want? How much more efficient could we be? Not just the efficiency of being able to, not reaching out to that person, but also the efficiency in our clinics and in our operating rooms. If we could cut down on the number of people who are missing it. And that's just like the first line, right? And then you think about patient intake. When you go to every single time you go to any doctor and you're going to fill out pages and pages and you're like, I think I've done this before, right? What if you could do all of that with your voice? What if you could, or I work in the emergency department. When you are in the emergency department and it takes 2 hours for me to come in and you're like, what if you had a system where you could just like talk to an AI voice agent on the other end and it knows the questions to ask, right? It is trained on all of the conversations that we've had with our ED patients and it knows where we're going to go with this. It knows it knows your patient history because it's connected to Epic and you have that conversation and you're not pressured, you're not rushed. And if you think of something later, you can be like, oh, hey, and there's another thing. And you get to add all of that in. What if you did it the night before your appointment, right? And then the doctor can just walk in and says, oh, Trudy, it sounds like you've been passing out a lot and you've been breathless. Boy, what if we talked about your heart a little bit deeper? And you're like, oh, I didn't even think about your heart. I was thinking about my lungs because of my breathlessness. All of that is technology that already exists today. If only we would have the fortitude, the ability to actually deploy all of that stuff. These are some of the other things that I was thinking about using that for. But so it kind of brings me to the goal, the vision, right? The vision is to bring us up because we've been trying for decades to improve healthcare out in the communities out there. What if we took that telehealth conversation where you're having a conversation with an AI voice agent and we took it to the next step? This is Amazon One Medical. So Amazon bought One Medical for $4.8 billion. And so now anywhere in the country, you can have a conversation with a physician for $50. And when you follow the money, this is Hippocratic AI. This is one of the biggest healthcare AI startups. They are currently valued at they are valued at $1.64 billion, but that number hasn't been updated in a year. And so what this company does is the product that I just described earlier, where you have a conversation with specifically a healthcare-focused large language model that's fine-tuned on your information. Silicon Valley thinks that is so valuable that they're putting this at $1.64 billion because what I think that they are going to do, and You can't find this in the news, but I think they're going to combine this with this. And the reason that I think that is because of this. So this is HR 238. So this was introduced in January of this year. When you say AI is not going to replace physicians, physicians who use AI is going to replace physicians who don't, I don't think that's true. And up until now, I've been very optimistic about AI, and I've been very encouraging that we should all be thinking about AI. And to take the other side of that coin, if you are pessimistic about AI, or if you're curious or concerned about AI, this should make you very nervous, because there is legislation to try to take us out of the game altogether, right? It essentially says AI and machine learning can qualify as a practitioner eligible to prescribe drugs. And so, whether you like it or not, I think this is going to happen. And the reason I think it's going to happen is because when you read between the lines, so this is from the White House, so this is America's AI action plan. They specifically call out healthcare. Many of Americans' most critical sectors, such as healthcare, are especially slow to adopt due to a variety of factors. A coordinated federal effort would be beneficial in establishing a dynamic, try-first culture for AI across the American industry. So, being a little bit realistic, I think this is coming. Whether or not we are optimistic about it, whether or not we want it to come, I think that the people who write the policies are thinking that AI is good enough to be a provider, to be a practitioner. And the question becomes, how can we then, knowing that this is going to come, maybe, knowing that people are trying to make this happen, how can we lean into this technology to use it for good, right? How can we be a little bit forward thinking? And knowing that 2035 is going to look very different from 2025. And what do we need to set up now in order to be ready for then? And that's why I was super excited when Daniel was talking about getting all of our data together, right? Because if we are not the ones to be thinking about this, these guys are. And what I did not include in this slide deck is Walmart, is Google. Google is spending billions of dollars all around the world trying to develop AI-powered tools and algorithms so that when inevitably it is okay for them to be providers, they are ready on day one to bring that right over. And I am convinced that they will bring a whole lot of good. And there is going to be a whole lot of positive change in the way that we provide healthcare. And also, I think there are going to be some growing pains if we are not thoughtful about it ourselves. And so the short story is I gave a version of this talk to our legislature, and I think that they are also recognizing the power and the opportunity that we have. Especially thinking about the future of data in Kentucky, and thinking about how now that we have this giant data lake, what can we do with it? How can we leverage the tools that already exist in order to make us a little bit healthier? One of those tools, or one of those things. How do I frame that? I would say when the AI action plan I showed you earlier, they said that they needed federal steps in order to push this forward. I think this is one of them. And this is the Rural Health Transformation Program. And to not get too deep into the weeds, when you look at the 5 pillars of the Rural Health Transformation Program, and I kind of assume that you guys know more about this than I do, probably, in thinking about the lifeblood of rural healthcare. But they talk about making America healthy and sustainable access and workforce development and innovative care and tech innovation. And they are leaning into tech innovation. When Dr. Steve Stack, the Secretary for the Cabinet of Health and Family Services, when he testified to the same group that we were talking to here, when he testified, he said that he thought that the Rural Health Transformation Program was going to be a tool to prop up hospitals to make sure that we could stop the bleeding. And that's not what it was, because what they wanted to do was to transform rural healthcare. And so the question is, how do we do that? And so when you look at the details here, you're using this money essentially to do many, many things, and a lot of them have to do with technology-driven innovation and artificial intelligence and creating data pipelines. And the idea is that we should all be forward-thinking, and how can, and that's the goal of the Rural Health Transformation Program. The short story is that I don't know anything of the behind the scenes, and our friends at the Cabinet for Health and Family Services, I do not I do not envy them in the least because the government gave them 6 weeks to figure out how to transform rural healthcare using AI and technology. And oh boy, good luck. I think about this stuff all day, every day for 3 years. And boy, I don't know how to do it. But we had some ideas. So UK got together, our Advancing Kentucky Together network, knowing that we think that this is where things are going, is we made a pitch. I'm just going to talk about that first line first. So right now, when you think about the way that AI is being integrated into healthcare, we're waiting for it to come through these major EHRs, right? And if I had a little bit more time, I would ask how everybody's integrating AI. But in general, at least at UK Healthcare, we're waiting for it to come through Epic. And then once it comes through Epic, then we'll deploy it, right? What happens if you don't have Epic? You know, what happens if you don't have a couple of $1 million to invest up front on AI stuff, right? Like what happens if you're an independent hospital? Do you then not get to participate in the revolutionary transformative technology that is artificial intelligence? Can we do it together, right? One of the things that we have been pitching, our group, is what if we created our own large language model based on Kentucky data, talking about the way that Kentucky physicians care for Kentucky patients. If we now have the technology, we've invested in the technology, we don't actually have it yet. We have invested in the technology to have this ambient listening system in every single one of our patient rooms, right? And so, which means that, one, our documentation is a little bit easier because now our physicians can use a large language model and it creates a note for you. But what if we also use that exact same data? Because now we're recording a conversation with every single gastroenterologist and every single OBGYN. And you think about, okay, well, if we have the practice patterns of all of our UK healthcare gastroenterologists, and we have the very unique ways, the very unique vernacular about the ways that Kentucky patients talk about their problems. You know, when they say they've been falling out for a minute, you know, falling out could be a seizure, it could be a stroke, it could be a lot of things. They could be just passing out. A minute, you and I both know, is more than a minute, right? What if we trained a language model just based on the way our people talk about their problems? In that way, it's more precise. This is the reason that I had my grandmother turn Asian. It's more precise because the way that we talk about our problems in Kentucky is different from the way that people in New York and New Mexico and Florida are going to talk about their problems. And so what if we built that together, right? Like what if we just built this as an asset that Kentucky could have so that we could all share in the ambient listening? What if we then took that to an AI-powered platform, like a telehealth platform, so that instead of waiting 6 months to see a gastroenterologist, what if we knew that we had this large language model that knows the way that gastroenterologists practice medicine in Kentucky, and then we use telehealth to kind of cut to the chase a little bit. So instead of waiting for 6 months, what if you we're able to talk to a large language model, and based on the historical patterns of the way that we practice medicine, it gives you some recommendations. Why don't you try omeprazole for a couple of weeks while we wait to get you into our clinic? That way, our gastroenterologists, one, don't have to be spending that time doing the initial interviews and the initial conversations, so they can kind of cut to the chase, and they could spend their time at the top of their license and do more colonoscopies and endoscopies, which means that you don't have to wait quite so long for an endoscopy or a colonoscopy, and everything just becomes a little bit quicker. Like I said, all this technology already exists. And then there's some other things about like remote patient monitoring and all the things that we've already been talking about all throughout this whole conversation. These are the things that we pitch that we think we can do. We think we can do this together because I'm afraid that if we wait for Amazon or Walmart, or if we wait for Epic, or if we wait for other people, then it's going to pass us by, or we're going to be paying out the nose for it, right? I think those are the, yeah, okay, great. So good. So 47 minutes. I went longer than I thought I was going to. I do want to hear though, like when you all think about artificial intelligence, like everybody here is here because, you know I'm the last speaker and you could have left when you're here to talk about AI. Why are you still here, right? Like what is interesting about this to you? What are the things that you guys are trying to do out in the community? How can we work together? You know, what are these big ambitious goals that we could do? Katie's got a microphone in the back if anyone wants to talk. But I think that this is the promise. I think that we have an opportunity that we've never had before, right? We've been trying for decades to make people healthier. Right? We've been trying for decades to figure out how do we decrease pediatric brain tumor. Now that we have this data, now that we have this technologies, what can we do to actually bring it to life? Yes, please.
Oh, I'm coming. I'm curious to know if you think that you have to build this platform and have EHRs tap into that, or do you try to integrate with your existing platforms?
Yeah, it's a great question. The what you're getting into there is the scattered way that we have our data housed right now, right? The good thing is that the 2015 Cures Act requires EHRs to use HL7. And so now all of that data should be readily scrapable and obtainable, should be, right? And so while there are definitely systems and networks out there that are doing this, to your point, it's very difficult, right, to integrate it into your infrastructure. I don't think we have to. To just very directly answer your question of if do we need to build this ourselves or can we use somebody else? Honestly, the conversation that that Danielle was having about the CCS and having that data network, what if that was the platform? What if we, and maybe it's not CRISP, who I don't know anything about from earlier today, but if already there is an infrastructure from the state, what if we just deployed little apps just like you would from the showroom in Epic? If everybody knows what that is, it's essentially like the Google Play Store, the Apple Store. There's a showroom in Epic where you can design whatever you want. And as long as Epic then goes through and does all of their privacy things and making sure that your data security is all up to speed, then anyone else in the country can do that. And so we have some of our students are working on apps for showroom. But to your point, like, do we need to build it ourselves? Maybe not. We just think that that's the most, we just think that that's the most equitable way of doing it is if we build it from within, then we can control things on the back end. We can control how much it costs so that it's not totally cost prohibitive, those kinds of things. Does that answer your question?
Yeah. Not everybody has.
Exactly.
They do.
Yes. So what I meant to say, or the way that I tried to, or in my head, when I brought up the Epic showroom is because if we design it ourselves and it gets the stamp of approval from Epic, we can also use that same technology and use it at Cerner, right? And we would host all the servers, we would have everything. That stamp of approval from Epic is just to say, is essentially to make sure that everybody is comfortable with our group essentially coding a bunch of stuff to use data, right? Because anytime you talk about data and cybersecurity, right? Like, are you going to I think that's the biggest barrier to integrating and implementing artificial intelligence is how do you trust somebody who wants to, like, I don't have a product. I'm just a pediatrician, right? But I think we can build it. And that's also why I showed the vibe coding thing at the beginning, because we're doing it. Like we're actually trying to build that infrastructure, to your point, for systems that don't have Epic. Yeah.
You have questions rolling in on the screen.
Yeah,
I don't know if you want to take questions from the live audience. Or if you want to do this and follow up with email.
Can I get a little bit of help with, will you address some of the concerns about the negative aspects that we hear about AI? What are the negative things that you guys are hearing, other than hallucinations, data privacy, security? Trust, yes. How do you trust the thing? Yeah, I think this goes back to where I think we're still in the very early phases of AI. And when you look at hallucinations specifically, right? Because the first thing that when it came out, everyone was talking about you can't trust the thing, it hallucinates too much. There is data that shows you that if you are using the main companies like OpenAI's ChatGPT, Gemini, through Google, they hallucinate about 1,000 times less now than they did when they first came out. That's not to say that they're 100%, right? And when you're talking about healthcare, you got to be 100%. But what I am saying is that in 3 years, we are 3 orders of magnitude better. And I think that progression is going to continue. And so to the point about the negative aspects, the other negative in my head, the negative aspect is that the technology is moving so fast, right? Like, let's say 2 years ago, you were very forward thinking and said, I want to invest in this technology. And you put $50 million into some kind of AI technology. And now I can do that on my phone, right? Like because it's moving so quickly, what are the actual things that you need to actually be investing in and spending time and training up your people? And so because it's moving so fast and because there are so many places where you could invest time, it's hard to decide, I want to spend my resources on this one project. What else? Any other negative thoughts about AI? I'm just going to look at any strategy recommendations for providing hesitancy in adopting anything AI. Strategy recommendations. Yeah, I think the tricky thing with adopting AI is because we've all seen ChatGPT hallucinate. None of us are willing to say, I'm going to trust that my chest X-ray is read by an AI, right? Like if it's your chest X-ray, you're going to want a radiologist on the other side. And so as much as we can develop evidence that shows that it works. And so, when we're talking about, do we want to build this platform ourselves? When we do build the platform, we're going to be reaching out to a lot of people in this room and saying, hey, we think that we can bring ambient listening to your mom and pop physician office without needing Epic. In order to do that, we're going to have to need a whole lot of, kind of data privacy and those kinds of things built in. But if we are able to do it, can we collect some data? Will you review the notes that you would have written and compare it to the notes that our AI system? Or one of the other use cases that is very common is responding to patient messages. And we've built a system that essentially responds to patient messages. And we trained it on the literature that we selected, we cultivated, and it's pretty good. And we think that it is at least as empathic and thoughtful as a physician. And could that mean that your patients get a little bit of a quicker message and anything that needs to be forwarded on? And so partnering with a couple of outpatient physicians' offices to collect that data could help there.
I think you've got a really good question at the bottom in the middle, especially with rural health. How are we going to convince rural Kentuckians to even use AI tools? Rural Kentuckians who are nervous to see a doctor in the first place.
Boy, that's a good one. Yeah, if you have the answer, if anyone, that would be awesome. I think what it comes down to is at least right now when we have total control over it right now, is we can say that this is not trying to replace your conversation with a primary care doctor or a gastroenterologist. It's an alternative option. If you choose to, instead of waiting 6 months, would you like to talk to this robot? And maybe they'll go like, yeah, I'll talk to the robot. And they're like, this sucks. And then they won't use it. That's fine. But maybe they'll find that it's okay. And maybe they don't trust it for 100% of things, but maybe they'll take the prescription and they'll try out that medicine. And then maybe they'll tell somebody like, you wouldn't believe, I talked to a robot. And so I think that's how it works. I think that if when people understand that we're coming at this from a perspective of we are all in this together. We just want to make our community a little bit better. It's not like we're trying to save $1 and not let you see a primary care physician. We're trying to bring that forward so that you don't have to wait. I think that's the message. I don't know. What are your thoughts? Any opinions there? Yes.
And also a liability as well.
Yeah. Yeah, what happens when it's wrong? Yeah, what happens when it gives a blood thinner to somebody and they have a stroke? What happens? All of those are well taken. I think that when we roll this out, it's going to have to be on super low stakes first for a long, long time before anyone is willing to trust it with some of that higher stake stuff. I like the one in the top right. An MIT study found that over-reliance on AI reduces critical thinking and problem-solving skills. Recommendations on finding the right balance. So I mentioned that we're putting together a course for AI literacy and competency, and this is one of the 5 learning objectives that we talk about. The idea is downskilling, right? Like if I have an AI whispering in my ear that, I should give this patient amoxicillin, then why do I need to know whether or not this patient needs amoxicillin? I'll just go in there, look at their ear, and say, what do you want to do? And so to that point, I think it's actually going to make us better because I think that we are going to be able to focus on the things that actually matter a little bit more, the complexities, instead of the rote and the boring, right? When I think about if you're managing somebody's blood pressure, how many numbers can you keep in your mind at any one time? I can keep probably about 5 or 6 blood pressure measurements. If you talk to a primary care doctor, they can keep probably 16 blood pressure measurements in their head. And they've talked to you for over time and they know okay, we tried labetalol and now we're going to switch over. And so they're pretty good at it. What if you had an AI that had all of that information, right? Who knew all of that, who knew all of the up-to-date evidence and who knew all of the recommendations for when things go. And so then you only need to focus on the edge cases. When things fall out of the typical, 90% of patients, most of us in here don't need complicated care. But when you do need complicated care, wouldn't it be nice to make sure that your physicians didn't need to focus all of their time and energy on looking up the dose of whatever fancy drug that you need now for your tumor or something like that? And so to the point about over-reliance, I think that there are going to be some things that are going to be downskilled, but I think that it's going to make us a little bit more exacting. Taking a step back, we talk a lot about evidence-based medicine and how standardized that medicine should be standardized, right? And that you shouldn't be practicing based on your own kind of anecdotal experiences, that everything that you should be doing should be grounded in evidence. When you look at the evidence is flawed, right? The data is flawed. The way that we captured this data is flawed. For years, we didn't even include women in this data. And so women have heart attacks, and it looks different from men. And it took us 60 years to figure that out, because we took a bunch of, the one very similar looking data set, and we applied it to everybody. And when you look at AI systems, I'm not going to lie. So one of the studies that we did was we looked at who goes into the training data, because as a pediatrician, it's important to me that a child is treated differently from an adult. My wife and I do some ultrasound stuff. And when you look at right now, there are 900 FDA approved AI powered tools that are available on the market. And about 75 of them are ultrasound specific tools, and one of them included pediatric data, and all of them are approved for use on pediatric patients. And that is scary to me, right? Because again, it's your grandmother turning Asian, right? Like children are different from adults. Sorry, no, I'm getting off topic. What is being done for data reliability and security when it comes to AI technology? Whoever asked that question, tell me more about that question. I think when you think about data reliability and security, specifically when it comes to AI technology, I think about where is your inference server, right? Like who is actually doing the AI stuff on the thing that you're doing, right? Like when you type something into ChatGPT, it's not like typing into the Google box. It is now that they've changed Google. But that data becomes public forever. And so if you just took all of your information and dumped it into ChatGPT, and then somebody else, let's say, I'm going to use my mother. My mother's in the audience. Let's say that they said, fill in the blank or complete this sentence. My name is Jeannie Tate, and I was born on 8958, and I live at this place, and my credit card number is, and then they say blank, right? If you happen to have all of your information in ChatGPT, there's a good chance your credit card number comes out of that. And so, when you talk about why does it matter about data security and privacy, and you can't just, throw your patient information into ChatGPT, that's why. And that's kind of scary. And so what's being done for data reliability? I would say that there are ways to circumvent that. There are ways to get around the model keeping that data. And anything that you do with healthcare, you're going to have to know that. What else? What other thoughts or questions? What are the things that you guys are using AI for already, or things that you're thinking, I'm probably out of time. Okay.